So what we're going to talk about today is writing numbers in standard form from scientific notation, and then the other way around, writing them in scientific notation if they're written in standard form. And then the last part is, we're going to skip this part for now. We're going to remember how to add and subtract numbers in scientific notation. Okay, so here we go. Starting here. So this is scientific notation right here. Scientific notation is a way you write either really big numbers or really small numbers. And the idea is to cut down the writing, but sometimes when you're first learning it, it's not cutting down all that much, okay? Here's the format, okay? You have to have the first number, whatever this first number is, has to be greater than 1. And then, but it has to be less than 10. Okay? So to be correct, the first number is always greater than 1, but less than 10. So whatever it is, it's going to be a decimal or it could be an integer, but it's got to be greater than 1 and less than 10. And then we always say times, and they use the actual X time symbol for it. And then you're going to have timesing it in scientific notation. It's always times a base of 10. And then you're going to have an exponent here on the 10, and the exponent will represent the number of spaces that you move the decimal. Okay? So hopefully that you remember that a little bit from last year, but if you don't, I'm going to remind you, okay? So this is called standard form, scientific notation, and we're going to put it back in standard form. That means without the times 10 in the numbers. So if you have 8.739 times 10 to the fourth power, what you do is, to put it back in standard, is this 4 right here tells you you're going to move the decimal 4 spaces. And because it's a positive 4, that means we're going to move it in the direction that's going to make this number bigger. So if I move the decimal left, is it really going to make the number bigger or smaller? Smaller. So I want to move it right because it's a positive 4. So I'm going to move it right 1, 2, 3, 4 spaces, but there's a blank there. Do you remember what you put in the blank? 0. Okay. So, and you do not leave your answer like this. Don't do it. It's going to get marked wrong every single time. You rewrite it. 8, 7, 3, 9. And now technically there's a decimal point right here. You're allowed to put that back in. But that's the answer. You don't leave the little wavy lines on there. So the answer is really 8,739. That's the standard form of that. That's how we would say it just normally. Okay, let's go again. The difference here is you have a negative exponent, right? So negative exponents, it doesn't make it a negative number. It tells you that we're going to move the decimal here 3 spaces, but we're going to make the number smaller. So instead of 3.72, I want to make it smaller by moving it either left or right. So to make it smaller, do I move it left or right? Left this time. So this time I'm going to go 3 spaces, but I'm going to go left. So if I go 1, 2, 3 to the left, and I fill these in with zeros, again, you don't leave it like that. There are 2 ways you can write this. You can write it as 0.00372 and leave it like that. Does anyone know the other way you can write this? It's also correct to write it with a 0 in front of that, like this. So you still only moved it 3 spaces, right? You can either put the 0 in front or not put it. It's both correct. Just like, I probably should have said it over here. I could have put a 0 behind that as well. It's still correct. Okay, let's do this again. What happens if you have no decimal point? This is a 4. So 4, no decimal point, times 10 to the 6th. Every single number has a decimal point. whether you see it or not. Where is it? Go ahead.
Wouldn't it be 87,000?
Huh? Nope, because it's only 4 spaces.
I know.
Oh, did I miss a 0 on that?
Yeah.
I totally did. Thank you, guys. All right, I'm sorry. You guys were probably confused. So it should be 87,390. I missed the 0, didn't I? And then the decimal's there. Thank you for correcting me. All right, on this one, where is the decimal point going to be?
At the end.
At the end, okay? So if there's not a decimal point, you assume it's at the end. So if I say like $5, right? It's like 5 and the decimal points after the 5. So this, I'm going to move it how many spaces? Am I going to make this number larger or smaller? Because it's positive, right? So do I move it left or right? Okay, so if I move it out right, and I'm going to write it here, 4 point, and I'm going to go 1, 2, 3, 4, 5, 6. How many zeros is that going to have?
6.
It's going to end up having exactly 6 zeros this time because the decimal point is at the end and there's nothing behind it. So this is really 4 with 6 zeros. Where did the commas go in? Every how many? 3. So what's that number actually in standard form? 4 million. Now, if you wanted to put the decimal point back on, you can at the end. All right, that's going from scientific to standard. Now let's go from scientific or standard form and write it in scientific. Okay, so that's the next section. So in this one, if you have 38,400,000, right? Again, where's the decimal if it's not pictured? At the end. So it's right here. So now we're going to go write this in scientific. So this is where this first rule becomes super important. This number is way greater than 1, but it's not less than 10, is it? To make it fit in greater than 1 and less than 10, where does the decimal point have to be, Malcolm? After the 3. So we actually need it to be right here. Okay, so I'm going to rewrite the first number as 3.84. And then once everything that's left is zeros, you can stop writing. Then we can write times 10. And then our exponent has to be the number of spaces that we must have moved the decimal. So let's count. It started here. That would be 1, 2, 3. Does the comma count as a space? No. 4, 5, 6 spaces, 7 whole spaces is what we moved it. Now, is it going to be a positive 7 or a negative 7? Positive, because this time you're looking at what you started with, and that was a big number, right? So that was a positive 7 that it must have started with here. All right, let's go again. Before we even start, is this middle number a big number or a small number? So is our exponent going to be positive or negative? Okay, let's go. Now, here's where this one has a decimal already. Where do we need to put it? After the 7. So when I rewrite it, I'm going to rewrite it as 7.29 times 10, and I'm going to count the number of spaces that I must have moved that decimal, which would be how many? 6. Positive or negative?
Negative.
Yay, that's the answer. Now, what throws kids off is when they're like, but this is not what, there's no zeros, and this is only 2,936.27. Okay, sometimes you get asked to put those numbers in scientific notation, even though they're not that big, right? Okay, for it to be in scientific notation, where's that decimal got to go? After the first 2, yeah. So let's do that. 2.9, sorry, that's a point. 36. Can I ever stop writing? 27. There's never a spot in that one where all the rest are zeros. So you have to write all the digits. Those are called significant digits, which if you take chemistry, you'll talk about those. Significant digits are all the ones where not all the rest are zeros. Okay, times 10. How many places did you actually end up moving the decimal? 3. 1, 2, 3 spots only. right? And is that going to be a positive or negative 3? Positive. You started 2,936.27 is actually a big number. The way you think of that is, would you want me to give you a check for that amount? $2,936.27. Would you want a check for that amount? Yeah. Would you want a check for this amount in the middle? No. Is that even a penny? No. You would get like a little teeny tiny microscopic speck of a penny for this one. Which, what are you going to do, right? Okay, skip the middle. Let's do this. Oh, do you guys remember doing this?
No.
Yes.
Okay. If you said no, then you better go back a little bit. Okay? All right, now, to add and subtract in scientific notation, you a lot of times you could type it in your calculator, but your calculator, even your graphing calculator, only has a certain number of spaces. So these are smaller because I want to fit it on here, right? But a lot of times we're talking about our exponents being to the 12th power or the 18th power. And so your calculator will not do it for you, okay? The way you do it is you have to write them out old school and add them old school. Let me show you. So 4.27 times 10 to the third. The first thing we're going to do is write this out standard. So how many spots am I going to move the decimal? 3. Okay, let's go. 1, 2, 3 really gives me 4270 decimal point. Yes? Okay. How many spots? Oh, this is a 4 again. So how many spots am I moving the decimal here? 4. All right. So if I move that out 4, I really have 3, 1, 2, 3, 4, 9, 7. How many zeros?
2.
Decimal point. Now you line them up and add them like you did in elementary school, okay? Because it's an add, right? So 4270 decimal point. Now line it up with a decimal. Decimal point 00793. Add them. Starting member on the right, not the left. So 0, 7, 9. 9 plus 4 is 13. What do we do again? Carry the 1, and we get a 4 here. Now you put it back in scientific. Okay? So if I put it back in scientific, where's the decimal going to go? Right after the 4. So it's really 4.397, and then I can stop writing because the only thing left is 0. It doesn't save me that much, but it does a little bit. Times 10 to the what power would it be? 4. 1, 2, 3, 4 spots. That's why it's 4. That's the answer. That's how you do it. Okay, so that's easier. Adding's pretty easy, right? Subtraction is only a little bit more challenging because you have to borrow sometimes. Okay, so let's do this. So for subtraction, so I'm skipping the middle one. Okay, first of all, how many spaces do I move the first one out? 6. Let's go. All right. So some of you can see this. How many zeros am I going to end up with on this? 3. Let's go. 9, 7, 3, 8, 1, 2, 3. You know, because 1, 2, 3 spaces are taken up by the numbers, right? And the other 3 have to be zeros. Decimal point. Minus, okay, how many spaces? 3. How many zeros? Okay. Okay, because it's 1, 2, 3 spaces, so there's 1 0. Okay, line them up by the decimal point. So here we go. 9, 7, 3, 8, 0, 0, 0, decimal point. Now by the decimal point, 0, 5, 2, 4. Minus this time. Okay, here we go. Let's bring our brains back to elementary school. 0 minus 0 is 0. Where do we borrow from? The 8. Okay, borrow from the 8. That makes that 7. Then what do? Add it to the next one. This is a 10, but borrow again, making it a 9. Now this one that we need here is a 10, right? 10 minus 5 gives us 9 minus 2 is
7.
7 minus 4 is.
3.
Then what? 3 minus nothing is 3. 7 minus nothing is 7. 9 minus nothing is 9. There's our answer in standard form. What is it in scientific? Go, Malcolm.
9.73375.
Okay. Times 10 to the what?
6.
Perfect. He moved it back to here, right? And he counted the spaces 1, 2, 3, 4, 5, 6 spaces. That's where the 6 came from. Ooh, all right. That's the first. Okay, so that's the first part of the lesson for 7-2. Okay, and so I cut the assignment. It's different. So the assignment, see how it's kind of cut, and then the other practice is on the back where it's the same thing. I didn't do any add and subtract on this one yet, but I'll get it on the next one. Okay, so your job is to either change it from scientific to standard or back, or tell whether or not it's in scientific. So like, for example, the first one on here, right? It says, is the number written in scientific notation? If not, explain. So the first one, is that written in scientific notation or not? No. Why not? Yeah, that's right, Angel. It's over 10. So this is a no because this number right here is too high, right? It can't go over 10. Does that make sense how you do that first section? Okay, beautiful. That is it for the day.